Alright students, so we're going to simplify trig expressions based off of the identities that we talked about yesterday. And I've got a copy of all the different identities here. So we're going to use these to replace more complex identities. For example, if you have a fraction of cosine over sine, we can replace it with cotangent. If you have a situation where you have sine squared plus cosine squared, you could replace it with a 1. So we're just taking expressions and simplifying them down. There's multiple steps that you can use to do this. Here's a few ideas to help you. First, you can turn everything into sine or cosine. You can factor. You can find a common denominator when you're working with fractions. You can expand your fractions. You can rewrite expressions without a fraction, and then multiply by the conjugate. And just to remind you of what it means to multiply by the conjugate, it basically means to multiply by a term that has the opposite sign. So if we have x minus 2 and we multiply it by x plus 2, when we multiply that out, you end up with 2 variables squared, the difference of 2 squares, x squared minus 4, which in a lot of cases what we're going to do is we need values like this to work with whenever we're using our identities. Okay. So the first problem we're going to do is expanding using division. And now, you may see this and to be able to do it more quickly, totally fine. You may even look at some of these problems and do them differently than I do. Totally fine. I'm just going through it very detailed so that it doesn't leave any question as to how I got some of the things that I got. Alright, so the first thing I'm going to do is I want to take cosecant and secant and convert them into sine and cosine. So before I do that, I'm going to take this fraction and I'm going to rewrite it so that I can see its the different ratios involved. So I just broke it out. Cosecant is on top, so it's over 1. Secant is on the bottom, so it's underneath 1. Now, I can use my reciprocal identity to rewrite cosecant. So cosecant over 1 is 1 over sine, and 1 over secant is cosine over 1. Those are our reciprocal identities. Then if I multiply that back together, I have cosine over sine. And then cosine over sine is cotangent. These are all on your identity sheet. These are my reciprocal identities. We have cosine and secant. We have cosecant and sine, the reciprocals of each other. And then we also have our cotangent identity. Cosine over sine is cotangent. So I'm going to state what I did here. Basically, I just rewrote this just so that I can see my ratios better. Then I used my reciprocal identities. I abbreviate, so I write down recip ID. And then I go ahead and multiply it back together. And then I replace it with my tangent identity. So with my tangent ID. Okay? Got it down. It's more simple. Basically this value right here, cotangent, is the same as my cosecant divided by my secant. Next. Sometimes we have to rearrange our signs a little bit. So this one, to start off with, I've got a sine in both of my terms. So I see that as a common factor, and I'm going to take that out. Also, instead of using x, I'm going to use theta. I like using theta better. It doesn't look like a letter as much, and it just keeps me from messing things up. So I'm going to go ahead and write that out with just the theta in there. Now to factor, I've got sine times cosine squared minus 1. So I just factored out the sine theta. Now, cosine squared and this minus 1 look very similar to a Pythagorean identity. For example, if I was to subtract cosine from both sides of this equation, I would have cosine theta equals 1, sine theta equals 1 minus cosine squared theta, where the 1 is positive and cosine is negative. Notice it's just the opposite here. So what I'm going to do is I kind of got to do some rearranging with my signs. I'm going to factor out a negative 1. So I'm going to take out a negative 1 out of here, out of my parentheses, and that's going to leave me with a positive 1 and a negative cosine. And when I do that, I now can replace this with sine squared theta. So I've got a negative sine theta times sine squared theta. And when I multiply these together, I want you to think of multiplying variables. If you have a negative x times an x squared, you would get a negative x to the third. Well, that's what happens with your trig functions right here. I get a negative sine to the third theta. And now you have simplified this as low as we can go. So, my first step, what I did was I factored, or took out a common factor. Next one, I factored out a negative 1. Then I used my Pythagorean identity, and I abbreviate that, Pyth right here. Then I multiplied. And that's how I got down to this one term. Okay. Factoring and simplifying fractions. Now, just like I showed you before with the variables, if you look at this and said, well, I don't know what to do with that. If I change cosine to an x, and I wrote that as x squared minus 4 divided by x minus 2, you could see that this is the difference of two squares, and can be factored as x minus 2, x plus 2. All of that over x minus 2. I have a common factor, and this is what I'm left with. Well, that's exactly what we're going to do, except we're going to use cosine instead of x. So my numerator is going to be factored to cosine theta minus 2, cosine theta plus 2, all over cosine theta minus 2. I'm going to factor out my common factor, and that's going to leave me with cosine theta plus 2. Now, I do have two terms, but unfortunately that's as simple as I can get it. So what we have here at the top is we factored, and then we simplified. And we're done. Alright, this next one's a little bit of a doozy. This one we need to find a common denominator. And to find a common denominator, sometimes the easiest way to do it is to multiply each denominator times the other. So if I multiply this denominator by the cosine of x, and I multiply this denominator by 1 minus sine x, then I'm going to have common denominators. But to keep my ratios proportionate, I got to multiply my numerator by the same thing on both sides. Okay. So up here at the top, if I have a cosine times a sine and a cosine, I'm going to zoom on this for just a second. Well, my cosines are going to end up being cosine squared. So this is sine, and I'm going to change it to theta again. Cosine squared theta minus, now, over here in my numerator, 1 plus sine times 1 minus sine. You gotta remember, we're subtracting whatever we get here. So I'm going to go ahead and put a parenthesis around this so I don't forget. No matter how many terms I have, I'm subtracting all of them. When I multiply, this is going to be FOIL. Okay? So we've got 1 times 1. Then I've got 1 times negative sine. And I'm going to have sine times positive 1. This positive sign and this negative sign are going to cancel. They're conjugates. We're not going to have that middle term. So then I can just go ahead and multiply my last term and get a negative sine squared theta. All of that is over my denominator, cosine theta times 1 minus sine theta. Okay. Now, this 1 minus sine squared theta, that's a Pythagorean identity. This is equivalent to cosine squared. So I'm going to write this as sine theta, cosine squared theta, minus cosine squared theta, all over cosine theta times 1 minus sine theta. Okay, now, there's multiple things you can do next, but what I recommend doing is taking out a common factor of cosine squared at the very beginning. So we're going to, and I'm going to block this off. Oops. So we have plenty of room to write. I'm going to factor out my cosine squared. That's going to leave me with sine minus 1 all over my denominator. Now, these are very close to the same thing. The only thing different is I need to factor out a negative 1 here. So if I were to factor out a negative 1, it would change the sign of each of these, and then I could cancel these out. But also right here, I've got a cosine and a cosine squared. So I can factor out a cosine. That's going to leave me with a negative cosine up here at the top because I'm factoring out a negative. That leaves me with 1 minus sine, and then that leaves me with 1 minus sine in my denominator. So these common factors cancel, and I'm left with a negative cosine theta. These get a little bit more difficult when you have to get the common denominators. So to start off, I did the least common denominator. Okay? Then after that, I replaced this with the Pythagorean identity. After that, I managed to factor. Ran out of room there. And then I was able to factor again, or simplify, take out a common factor, and then this is what I was left with. All right. So much more difficult We'll be practicing some more of those on down the road. Let's take a look at this one right here, to rewrite without a fraction. Well, we have a fraction right here. I'm going to get rid of that. And here's how I'm going to do it. Sine squared theta. Anytime you've got a sine, cosine, tangent, any of those squared, you can use a Pythagorean identity to help you. Okay, camera's kind of being a little funky right now. So I'm going to replace sine squared with 1 minus cosine squared. And that's over 1 minus cosine theta. I can rewrite 1 minus cosine squared by factoring it, and that would give me 1 minus cosine theta, 1 plus cosine theta, all over 1 minus cosine theta. Now, common factor. Be careful. You're left with 1 plus cosine, but you are subtracting it. So that means I've got 1 minus 1 minus cosine theta, because I've got to distribute the minus to both terms. That leaves me with a negative cosine theta. And I'm done. Up here, I used a Pythagorean identity. I factored. I simplified. And then I simplified again. Simplified, took out a common factor. It's really however you want to word it, so that you remember what you did when you look back at these. This is just to tell you what it was, the thinking process, what you were doing. Okay, the last problem. We've got our odd and even functions right here. Now, if you remember, our odd function, if we have a sign of negative x, we can rewrite that as negative sine x. And if we have a cosine of negative x, it's the very same thing. We get the very same result. So it's cosine of x. So I am going to rewrite this using my odd-even identities. So I've got negative sine of x over cosine x. Now, sine over cosine is tangent. But since I've got that negative out there, that's a negative tangent x. So this is my odd, even identity, and then this is my tangent identity, and this is my final result. Alright, on the back side are some problems for you to try, to practice on. Look at the answer key to see what you're supposed to get, and then I want you to work these problems down to try to get that result. You can look at the key if you need to as guidance. It's tough getting started. But these first 5 should be pretty easy for you to do, or easier. And then the rest are a little bit more difficult. See what you can do. Look at your identities. You're replacing. That's all you're doing, is replacing cosecant, trying to relate it with something with sine or cosine. Same thing with tangent. Relate it to sine or cosine. That's one of the easiest ways to get started. Okay, do your best, and then I'll see y'all in class.